Hi everyone, really nice to be here. My name is Max and I will talk to you about democratizing your data with analytics engineering today. And shortly about me, I'm the co-founder of a consultancy company in Stockholm called Signific, and I've been working with data and product development in different roles at companies like SVT, Voi, and currently at a startup that I don't think you've heard about yet, that's called Chroma. And we at Signific, we work with both product development in a data-driven way, a lot with A/B testing, analysis on and building products in a better way, but also data, which I will talk a bit more about today. And those two kind of cornerstones is how we help companies transform into becoming better companies, essentially. But enough about that. Today I want to talk about analytics engineering, and I'll start off by giving an intro why analytics engineering has become a thing in the data space, and then 4 areas around analytics engineering to nail in order to succeed. So business knowledge, a bit about the data UX, as you can call it, data modeling, which is kind of the core of what an analytics engineer do, and then what engineering best practices we can borrow. But yeah, so why has analytics engineering become a thing? This could be a current state for a lot of companies, at least a lot of companies we work with. So you have on the one hand, you have your data engineers, of course, that extracts the data from the sources. This data then, as you know, in many cases get dumped in a data warehouse. There are several alternatives to that. And then you have several different end users on the other side, like data analysts, ML engineers, business users looking for answers. And this has previously been a bottleneck to kind of do the data engineering. It's been mostly the bigger companies that have been able to do it, but the last years a lot of this has been democratized and more easy to do with the help of better tech, essentially. But so there's much easier dumping in data and getting that to a data warehouse, but still these end users don't really get as much value as they could, because this data warehouse in many cases becomes like a black hole that nobody owns. And this is perhaps not an exact statistic, but like around 80% of time is wasted there. So the data analyst has to go into the warehouse to find the data engineers has to help out all the way to the end users, ML engineers spend most time cleaning up the data, and business users don't even get the answer they look for. So this causes, of course, many issues. Essentially, it's a huge barrier to use our data in organizations. And as I said, time is wasted on these repetitive tasks to do cleaning of data all the time in the data warehouse. And what this leads to is less learnings and less value created from our data. So this, of course, we want to change. And this is where analytics engineering comes in. So it is a role kind of in the middle of data engineering and the end users. So if we compare it to those different roles, it's a bit closer to the business, as I said, than data engineering, but also more engineering focused than data analysts and scientists. And I will get into kind of how that works. But also, this is perhaps something that a lot of you people can compare to the role of a BI developer. It has been around for several years. But I would argue that an analytics engineer and the way of approaching this with analytics engineering serves more use cases than traditional BI development that is usually focused on the BI tools such as Tableau or Power BI, whereas data analyst takes a bit different approach. But so an analytics engineer, one definition of it could be that what they do is democratize data through relevant, trustworthy, and cohesive data models. And democratized data, what is that? For one, it's relevant. So we need to ask ourselves, what do we need to understand and learn in this company? That's kind of the first thing you should nail. And then it's also accessible. So you have to ask yourself how, when, and where do data and insights get consumed? But it also needs to be quality assured. We can't just have relevant and accessible data if it starts showing the wrong numbers or if it doesn't work all the time. So that becomes down the line a really important aspect as well. And then we also need to make it cohesive, or we need to be able to collaborate around our data in order to scale and really democratize it throughout the organization. So essentially asking yourself, how can others make use of and collaborate with this data? So this is what an analytics engineer do, but what do you need to succeed in this role? So I've divided this up in 4 different areas. One is that you need a solid business knowledge, perhaps more than common data engineering. You also need to think a lot about the data UX and the user experience around interacting with your data. Of course, data modeling, and then test tech best practices. And I'll go through each one of them at a time. So the first one, know the business or business knowledge. So this is what's focusing in on the relevant part of the definition of an analytics engineer. And I'd argue the first thing you should really nail and the first thing you should focus on. And there are 3 ways to create relevant data models. One is start by asking yourself, how do the company create value? Then how is that value measured? And then another common hack to kind of find relevant data models is to how can we connect user value to business value? These are common requests from the business to know, and this is what we want to translate into relevant data models. Might seem a bit obvious, but it's usually not perhaps the task and questions that you ask a lot to yourself as a data team or as a data engineer or analytics engineer. But then how the company create value? This can be done in many different ways to get this understanding. You don't have to use a canvas like this, but it's just to highlight kind of that looking at the business from all different sides. As an analytics engineer, you need to understand both kind of how a company provides value, but also how is the cost structure, the revenue streams, kind of get that 360 overview of the business. It's also about, as an analytics engineer, to know the organization. If you want to serve your end users, you need to know their problem. You need to treat them as users and understand their pains and gains. And in a company, there's usually a lot of different functions, and you should spend some time understanding these different areas. Another part of knowing the business is adjusting for your own context. There aren't one size fit all in terms of data modeling and in terms of getting value from our data. You have different types of products, different segments, different markets, seasonalities, languages, etc., and many more things to adjust to. You can also look at other similar businesses. Usually you're in one of these business models. It's either a SaaS business, marketplace, e-commerce, media, some of these, or a combination of them. There are many things written and many things said about each. That can be a hack for an analytics engineer or a tip to analytics engineer to start looking at how the other companies do it. But essentially, successful analytics engineers have a grounded understanding on how a company creates value, because this is what will help you build relevant data models. Then looking at how value creation is measured in a company. Usually if you want to really democratize the data, you need to understand how is data used in the company. Usually companies have this kind of vision and North Star metric. That's really good to have an understanding where is everything pointing towards in a company. Sometimes they also work with different objectives. You can argue about how you want to lead a company in terms of goals and measurements, but the common way is objectives and key results. For an analytics engineer, it's really important to understand this, because this is essentially what your data models will serve in the end, or they should serve in the end. So spend some time understanding this and really asking in your organization, how is value measured, what goals do we have, how can I support you to understand these objectives and understand that we're reaching them or not. So yes, analytics engineers understand what metrics are important and how they're used. And then the last one is to connect the user value to business value. So as I said, this is a current state. But if we look at it in an even more simpler way, you have data producers and data consumers on one side. And these data consumers usually have wish lists like this. They want to, as I said, track the KPIs, track different metrics. They also want to understand different funnels of the business and the product and the customer journeys. and look at different user segments. So as an analytics engineer, I would recommend spending a lot of time understanding this in order to build the data models for the processes that support this. And there are some ways, of course, of doing this. As an analytics engineer, I would really recommend getting out of the data warehouse and looking at the product and talking with the users. One thing you could do is just testing the product yourself, making sure do we have measurability all the way. You can talk to colleagues that meet users. How would we like to model the kind of way we see our user journey? If that's not possible, and if it's an early stage company, perhaps even talking to users yourself, just making sure you understand this is how our product is working, this is how our processes in the company is working, and this is how I can perhaps support that with my data models. And in the end, ensure that we have measurability all the way. So, and this is really a really important thing in order to create relevant models, because if you can translate the user value to the business, that really makes them more insightful and smarter. So spend some time on that. And a lot has been written about this, of course, in better ways than I say it, both in terms of OKRs and metrics. So if you're new to this, as coming more perhaps from the engineering side, or just in general new to this, these are some books I would really recommend in terms of finding good metrics, understanding how do we evaluate different business models, and how do we steer companies through that. But also then around products and how do you do data-driven product development, and how can I match my data models to support that kind of work. So the first area then, to know the business. Understand the business model, understand the important metrics for your users, that's the most important thing, and then spend some time connecting the end user value to business metrics. So there we have the business knowledge. Then moving into the data UX. So this is essentially about the core thing of democratizing the data in the definition of an analytics engineer. So it's about making the data accessible. So asking yourself, as I said, when, how, and where do data and insights get consumed? So looking at this side of the slide, or of the data warehouse. So what are the needs and the capabilities of your users? And one thing is that everything doesn't have to be a dashboard. And in order to really democratize data, you can ask yourself, how can we achieve more self-service in the organization to get insights and use data? So when, as an analytics engineer, building different data models to support this, I would argue for taking an approach where you do this in iterations. Don't sit down and try to make everything perfect and spend a lot of time building the perfect data models. Sit together with your users and build out the model from that. And this might take some more of your time in the beginning. So let's say you have a first iteration of a process you want to model. Then if this is how much time is spent for the analytics engineer, and this is how flexible and big the data model is, for the first iteration, you might spend a lot of time building this model and spending a lot of manual time building it out. But then the second iteration, and the user might come back with a deeper question. You build out on that model, but you do it based on their needs and their wants. So kind of doing it in iterations together with your user. But at the same time, also building out the data model to serve different use cases. And the main advantage with this is that value is delivered at each iteration. Rather than spending a lot of time building a model that might not be valuable, might not be relevant, you constantly deliver value, deliver insights to the organization or to your end user, but at the same time, you're keeping in mind building out a data model that serves more purposes. Because where you want to end up, perhaps on the fourth iteration or whatever number, is kind of where the end user can just go into the data model using it by themselves, and in that sense have a more self-served model, and that is where the data gets democratized for real. But I would argue that getting to that point is best done through iterations where you really sit together with your users. So iterate your data models. But truly democratized data takes more than just great data models. Even though you go through this and you do these different iterations together with your end users, in my experience, you usually not get all the way anyways. And there are some reasons for this. In organizations, there might be a lack of data knowledge, so they don't know the possibilities of what you can do with your data. They don't understand the context that they're in. They don't understand what metrics are important. How can we use data in product development or in sales or different areas. And there can also be a data literacy, so their ability to work with data, essentially. Can they solve their own data question? Do they know the tools that you have in order to get the insights? Can they code themselves? In many cases, there are different levels at the company. You might, in some companies, you have these kind of data champions that can be really flexible and work with the very independently, but in a lot of cases you need to kind of help others on their way through there. So there are different tactics to kind of improve this self-service depending on where different individuals in a company are in terms of data knowledge and data literacy. So looking at, for example, this colleague that has high knowledge, they know the data, they know what they want to do with the data, and they also have quite high literacy. They can work with perhaps your BI tool, or they can code themselves or find the data through SQL from the data warehouse. These people, usually sometimes called data champions within an organization, for them, I would spend most time documenting just how is the data warehouse set up, how can I access different things just to make their life easier. They know what they should do, they know what they're looking for. Spend time making sure it's easy to find through proper documentation. Then you have another type of user who has perhaps low knowledge, not really knowing what data you have and how you can use it, but they have high literacy. It can be an engineer knowing how to get the data, knowing how to work with it, but not really sure what data should I look for. For these users, I would spend more time onboarding them, and this is the kind of possibilities we have. Again, of course, pointing to documentation, but spending more time coaching them in terms of how data can be used in their context. Then going a bit to the left, so lower literacy, not as good with data perhaps as on the right, but you also have this group that is also not as knowledgeable. So these are really they are just starting out their journey on working with data overall, and there are quite a lot of these people in many companies, of course. Here I would spend more time evangelizing around data, just showing, building the hype a bit around this is what you can do, perhaps doing some proof of concept, getting them to a place where they really want to work with data. I talked to one here in the audience before the talk that a lot of companies have kind of come to the level where everybody wants to be data driven. Essentially, it's not something that you have to convince everybody about. But there are still some people that perhaps feel there are some barriers to do that, and help them through evangelizing how easy or how good it can be to work with data. And then you have if you manage to do that, you improve their data knowledge, but they're still not as literate. What a lot of companies are investing time in is these kind of data camps, or making sure people kind of take the step to become more data literate. And here is also something where an analytics engineer can really help out to level up the data literacy of their colleagues. This can be done through frequent meetings, coaching sessions, and perhaps even courses internally where they can kind of take the step in order to work to themselves find their insight and become more self-serving. And in many times, at least in my experience, it's often just a few. Just need some basics in order to get started. There are some hurdles. Perhaps if I just knew some SQL, I can start working, or if I knew Tableau a little bit better, or I just have this little thing that's stopping me from working. So it's not that you have to teach people how to code, or you have to teach people how to use a tool all the way. But these are important tactics, and this also really increases the value from your data models. You can have the perfect data model that's super relevant and super useful, but if people not using it, then it's not creating value. So also spend some time on these different tactics and think about who am I helping, and choose the tactics from that. And how do you know if you're doing a good job? Is of course perhaps a hard question, but one way of looking at it is, are people asking more deeper questions around our data? If I provide them with something, are they coming back with, okay, now I want to know this? It's perhaps a qualitative metric, but a really strong indication of that people are actually becoming more data-driven, and that the data are becoming democratized. And then you can look at, is the company using data when they make decisions? Are they showing data on their demos? Are they showing it on their quarterly meetings? Is that something that's changing? You can of course survey perhaps your company around the use of data. It's also a good tool, but essentially this is kind of qualitative measures of if you're doing a good job as an analytics engineer. But then you can also do this more quantitatively, looking at, are my data models being used? And that is a really good metric if it's a relevant data model that's helping the business. So when working with data UX in a company, as I said, iterate together with your end users. Don't sit and think about how should I do the perfect model from the start. Do it together with your users. Choose different tactics in order to improve the self-service and improve the value of your data. And also give this change some time. It won't happen overnight. People won't become data champions in a week, but you kind of work towards that at least. So there you have the data UX. Then going into the data modeling, and perhaps the core part, as I said, of what an analytics engineer do, the actual data models. And going back to this current state, and if you start building out these relevant data models, it can sometimes end up like this. So I have this messy warehouse with a lot of different models serving different use cases, which is great. We're delivering value, but this also over time becomes quite hard to manage and quite hard to work with. So in order to, and then there will become more use cases, and you will have to do changes and such. So in order to serve a lot of use cases as a data team or as an analytics engineer, you need a flexible foundation. And there has been a lot of debate around this in the modern data stack community and the people who have been working with data for a while, that you can't just go bananas in your warehouse and have a bunch of different models and nobody knows really what's going on. And I think there's a middle way there where data modeling really comes in and making use of what we have learned in the past. But essentially the steps of data modeling is of course understanding the source data, and with your business knowledge and your knowledge on data UX, what processes are important and how is that data generated. I won't go into too much detail about that. It was something that Lars and others talked a bit more in detail on the data engineering side. But rather than structuring that raw data as something that analytics engineers do. And a proven approach to this, and something I would argue is time well spent once you know what's relevant and once you know the UX, is looking at different ways of modeling data. And one is star schema. It's a data model optimized for analytical queries, and it's a fairly intuitive thing to navigate for most people and relatively easy to set up. So what this is essentially, if you haven't worked with it before, is you have this kind of events or a fact table in the middle and then breaking out the dimensions. And the goal is to kind of have this cohesive structured data where you have all the events that describes a certain process where you can easily join and combine that data. This is something that has been done a lot before. This is not something new, but again, something that perhaps the more modern approach to data could draw a lot of benefit from. And this structured data is great, but again, it doesn't really cover everything. As I said, when you have low data literacy in the organization, even though you have this nice star schema with the data really structured, it can still be too hard for them to work with that. And also when you have use cases that touch several processes and you need to join data in order to answer a certain business question, you need to take that into account. And in some cases, you also have some recurring questions that could be answered more easily. So always, and again, continue to adjust for your consumers. So if you look at the different approaches in terms of modeling, you want this kind of foundation of a quite high complexity, not super complex, but quite high complexity, but also high flexibility with separate tables, such as a star schema. Then serving some users, you perhaps set up some join tables, and you have that as kind of a next step, and then you have your ready-to-use reports or ready-to-use tables. So to the right, it's lowering complexity, but it's also lowering flexibility, but you should spend some time in having this kind of flexible ground. So keep focus on solving the end user needs, but find a flexible model in order to serve the already confirmed use cases. So this is just the summary of that. And there are, again, here some reading tips on this as well. Ralph Kimball, of course, a legend in this space and how to set up modeling in the data warehouse. I would really recommend this book, the Analytics Setup Guidebook, which is free, if you're interested in this. And then, of course, there are so much things written about this that we can draw benefit from. So there you have the data modeling side of analytics engineering. Last piece. Let me see where I am in time before. All right. Take best practices. So as an analytics engineer, we also should produce trustworthy and cohesive data models. And this is not always the case, to my experience, when you're working with data and helping companies in this area. These transformations, when data get into the warehouse and then gets ready for analysis, usually become these kind of black boxes. So let's say you have a customer segmentation where you do a lot of different wrangling and a lot of stuff, and then data is ready for analysis in some tool. Or you have an attribution model of how do we get customers from different channels. But this becomes these kind of black boxes where a lot of things is happening from going from raw data to analysis, and you don't really know what has been done and what's going on. So there are some problems with this approach, and this is a common way when you start. You're doing something relevant, you're doing something that's really accessible, but it's still a black box. It becomes really difficult to change. It's really hard to troubleshoot if there is something wrong with the dashboard or there's something wrong for the end users. Finding where in this black box the problem is really hard. And it's also a nightmare to collaborate on and to hand over. And this we, of course, want to solve. So instead, we want easily worked code. We want to be able to fast and frequently and safely release new changes. And we want to simplify collaboration. And this is something that, of course, software engineers and other product developers are fairly familiar with. This is something you want for most products. So let's borrow something from them. And essentially, analytics engineers that succeeds treat their data transformation as you would do with a software product. So something that you can borrow from software engineering is 3 different things I want to go through. One is splitting up the code. Other is CI/CD, and then different ways of working. So splitting up the code, this is, I won't go into detail about this at all, but this is a common practice within software engineering to kind of split up your applications that in different parts that serves different purposes. And it's not about these different approaches here, it's rather taking that thought. So looking at our black boxes of transformation, we usually go through a bunch of different steps, and perhaps we have a cleaning of 2 different sources, we join them, we do some calculations, and we do some structuring. And splitting it up in different pieces, where you have one transformation that serves one purpose, makes it a lot easier to work with, a lot easier to troubleshoot, a lot easier to test, and a lot easier to collaborate on. And then also you can, with this approach, you can reuse what you have done. So let's say we have this cleaning and joining, from that we can draw different calculations and different structuring for different use cases here. But we don't have to start from the beginning at every process, which saves time and democratizes the data even more. So yeah, some advantages with this approach. It's more clear and more readable. Of course, it's also testable. You can test each step as it has a certain purpose. And it's also a lot more reusable. So splitting up the transformation in different modules is something good analytics engineers do. Then we have the quick and safe releases. So we can assume that change will happen. As I said, we can't know everything beforehand. Data coming in will change. We will add new data sources. The data sources will change. And also the needs from the end users will change, hopefully. So this is also common in product development. How do software engineers solve this? They work with the different areas of CI/CD, and this is something we can borrow. So looking at our transformation here of cleaning, enriching, calculating, structuring the data, in the data warehouse, this transformation, of course, should be version controlled. This is not always the case, but I would really recommend versioning controlling your code that does this in order to roll back, in order to understand and move faster. It's also about orchestrating this whole flow and writing tests and making sure you're monitoring this, and then also documenting in this. So good analytics engineers really spend some time doing this once you find the relevant accessible data. And there are a lot of different tools here that has been coming up. Some are old, some are newer. dbt has become a really common tool within the data space. But yeah, essentially, you should version control, test, and document your code in order to safely make changes and safely provide more, or fast and safely provide more value. And then last thing, perhaps an obvious one for most of you that's been working in agile teams, but when sometimes in a lot of companies you're kind of a lone analytics engineer, or you're just a small data team, and this comes with a lot of risks. For one, of course, all knowledge sits with one person, and it's hard to keep up with all the needs from the different end users, and this over time creates technical debt as you take some shortcuts, or you do what you think is a good solution, and it's not something we want to do. So software engineers usually solves this and collaborates around the code with code reviews. That's something you could borrow and should borrow over time. So have either a junior or a senior colleague working together on your code, doing this kind of monthly syncs where you look at your transformations, you look at the different use cases, how do we serve that, and then spend some time doing bigger refactorings. So this is something that will help you build more trustworthy and more cohesive data models. So you should optimize the ways of working for collaboration down the line. So when borrowing from tech best practices, treat your data as a product, aim for readable, testable code in separate modules, and then ways of working for collaboration. So yeah, as a wrap up, these were the 4 different areas for an analytics engineer to focus on. And I know it's hard to be the best at everything of this. It's almost impossible, I would say. And there are different profiles that could serve work better in different companies and different settings. So like if you have a really strong business knowledge, that might be good when starting out your data journey. You know about what do the business need, and you can build those models in a fairly good way. But once you want to scale, perhaps data modeling and tech best practices becomes more important. And then as a team, you should also think about, if you're more than one person, how can we serve these different kind of needs? And then just as an ending note, now we've been talking a lot about the analytics engineer as as one role and one person, but data is a team sport. So eventually we'll get to the question, how should we organize in order to really serve the different use cases we have in our organizations, how to really democratize the data and work faster. So going perhaps from a central approach to a more hybrid and then completely decentralized, but that's for another talk, I think. So yeah, that was that. Thanks a lot.